All right, folks, Fast Action is back in action here. We're going to look at our last of our characteristics of our polynomials, and then we're going to put it together into an example. So taking a look at step 6 here, maximum turns. As we mentioned earlier, the degree of the polynomial is really important. It told us the number of solutions that we would have. It also helped us with end behavior, and it's going to help us again. The degree, if our degree is n, that will tell us the number of turns that our graph could potentially have. It says that it will have at most the degree minus 1 number of turns. Now remember, that isn't at most. It doesn't mean that it has to have that many. So the first thing that we can do is we can go through our 4 examples here, and we can find those highest exponents so that we can find all of our degrees. That means that the number of turns that each of these graphs could potentially have would be that degree minus 1. So my first example here would have at most 1 turning point. That makes sense. It's a parabola. We understand that's going to turn at one place. Next, we have our cubic that will have as at most 2 turning points. It, of course, doesn't have to have 2, but it could. Our next one we have here is our degree 4. That's actually our power function that we looked at earlier. It could have at most 3 turning points, but we understand that the power function itself does not have all 3 of those. Our degree 5 could have at most 4 turning points. Next, we're going to look at multiplicity. Multiplicity is the number of times that a particular zero occurs. So what we're looking for is repetition. That's all multiplicity is telling us is it's the repetition of a particular zero. So let's start off looking at the 0 of 3. So I've given you a function. I've listed off all of the zeros. So if I look at the 0 of 3, I can see that that 3 has been repeated twice. That means that its multiplicity is 2. And if its multiplicity is 2, 2 is an even number. So now we understand that our 0 of 3 has an even multiplicity. Next, I can look at my 0 of 4, and I can see that 4 has only occurred 1 time, and 1 is an odd number. So my 0 of 4 has an odd multiplicity. Lastly, I can look at my 0 of a negative 6. I meant to highlight that there, sorry. My 0 of a negative 6, and I can see that that 0 has been repeated 3 times. 3, of course, is an odd number, so my 0 of 6 has an odd multiplicity. Now, how does the multiplicity help me? It helps me understand how the behavior of the graph, what the graph is going to look like at those particular zeros. So, for example, zeros that have an odd multiplicity will actually cross the axis at that value. Now, if it has an odd multiplicity more than 1, in other words, a 3, a 5, a 7, or anything like that, what your Algebra 2 teachers might have mentioned is that it will create this little snake. Okay, so it will have like a snake look to it as it passes through that particular 0. In fact, when we look over here at our graph, we can see that we have this type of snake behavior right there. My even multiplicities will just touch the axis at that point. And your Algebra 2 teachers might have referred to this one as a touch and turn. That's a pretty common name for that one, a touch and turn. And when we look over here at our graph, we can see that we have a touch and turn right there. So now let's start to put everything together and actually come up with an equation for this particular polynomial function. So the first thing that it asks us here is it wants to know, is the degree for our polynomial function, so is our degree, is it even or odd? Now, how can we tell if it's even or odd? Well, let's think back to the previous page. We understand our even and odd behavior by looking at the ends of this polynomial function. So if I look at the ends of this polynomial function, what I can visualize here is I can visualize a positive sloping line going through these. Lines, of course, have odd degrees, so this polynomial function must be odd. So it's something odd. I also know, since it was a positive sloping line, that my leading coefficient is ultimately going to have to be positive. Now, if I want to actually find the degree for this, if I actually want to identify what is the degree, okay, I actually want to determine that degree, what I'm going to do is I'm going to go back and I'm going to look at my snake and I'm going to look at my touch and turn. So my snake tells me that this, okay, so I'm going to look at this snake and I'm going to identify the fact that this is going to count for 3 zeros. So I have 3 zeros right here at a -4. And then my touch and turn, this is going to count for 2. So I've got my 3 plus my 2. So I have a degree of 5. And that, of course, is exactly what I was expecting. It was something odd. Now it says find each zero and determine its multiplicity. Well, we've actually already answered that question. We can see that my x equals -4 has a multiplicity of 3. And we can see that we have x equals 1, and it had a multiplicity of 2. The last thing that we can do is that we can actually put all this together and we can actually write the equation for this polynomial function. So we can actually start off and we'll simply say our y equals, I'm going to put it in a because I don't know my leading coefficient yet. I'm going to write my factors, x plus 4. Remember that had a multiplicity of 3, so I'm going to write that as to a degree 3. And then I'm going to have my x minus 1. It had a multiplicity of 2. So I've got my 2 there. I can see on my graph that my graph is passing through the point up here. It's passing through the point 0, 4. So I can actually plug that point in as my xy pair. So I can put a 4 in here for y. I can put a 0 in for x. And then, of course, the rest of this will all stay the same. Now, if I clean this up, I'm going to have a 4. Of course, I'm going to have my a, my 0 plus 4. I'm actually not going to expand this. I'm going to leave this as a 4 cubed just so you can see what's going to happen. And of course, my 0 minus my 1, I square that, is just going to be a 1. Now I can go ahead, I can divide both sides by 4 cubed. So those, of course, will cancel. And on this side, this was a degree 1. So that's going to cancel, become a 1 there, and that'll become a 2. So my a value turns out to be 1 over 16. Didn't even need a calculator. So my final answer, my a value is 1 over 16, x plus 4 quantity cubed, x minus 1 quantity squared. And that is our final answer for the polynomial function.